As the Earth's climate is changing, rising sea levels are affecting low-lying coastal cities in the form of more frequent tidal inundation and coastal flooding. In many places, both the frequency and severity of extreme flood events have been rising, and scientists expect this trend to continue or worsen in the future. Even nuisance flooding events, minor flooding which causes public inconvenience, have dramatically increased in frequency over the last 50 years. To better plan appropriate responses, local decision makers need coastal intelligence in the form of accurate data to gauge the likely impacts of higher water levels. Geospatial infrastructure provides these data in the form of very precise and accurate positional information from both land and water level observations. On land, continuously operating GPS reference stations, or CORES, use permanently mounted GPS antennas to receive signals broadcast from global positioning satellites orbiting the Earth. Using CORES in coordination with their own GPS equipment, surveyors are able to obtain high-accuracy coordinates and elevations at any point of interest at the 1 to 2 centimeter level of precision. These coordinates are expressed with respect to national reference frames. These are defined and maintained by NOAA's National Geodetic Survey as part of the National Spatial Reference System, NSRS. But in coastal communities, land elevations only tell half the story. To predict coastal flooding, these elevations must be referenced accurately to local water level observations. Tide stations, another key component of geospatial infrastructure, provide this detailed tracking of local water levels over time. The long-term averages of water levels at different stages of the tide are used to define local tidal datums. These include mean lower low water, mean sea level, mean higher high water, and others. Due to hydrodynamic effects, these datum values are only accurate for a limited area along the coast, in the vicinity of the tide station. Tidal datums, computed for each tide station, are referenced to a local network of permanently fixed points called tidal benchmarks. These benchmarks are used to measure the stability of the tide station relative to the land over time. By using GPS on these benchmarks and by referencing to nearby CORES, surveyors can relate the tidal datums from tide stations to the NSRS. By connecting tidal datums to the NSRS, they can be accurately related to nearby land elevations. With this geospatial information, community planners can assess recurrent high water risks to roads, schools, hospitals, and other critical infrastructure. They can also predict how sea level rise will change the risk of future flooding and identify areas of vulnerability. Models can fill in data gaps where critical elevation and water level information is not currently available. However, this information is less accurate. Communities may decide to strategically invest in new geospatial infrastructure as a way to increase the precision and accuracy of their local data. Precise and accurate measurements from geospatial infrastructure improve coastal resilience and allow communities to have confidence that levees will be built high enough, to understand how long evacuation routes will remain dry, and to update building codes to protect homes and businesses from coastal flooding. Using the geospatial information already available through NOAA, combined with strategic local investments, geospatially enabled communities can more confidently define the relationship between elevations and water levels and better plan for an uncertain future.